Imagine a place where the very fabric of space-time crumbles, where gravity reigns supreme and not even light can escape its clutches. We're talking about black holes, my friends, and now we will talk about the biggest 5 of those enigmatic cosmic behemoths discovered so far. Fasten your seatbelts, because we're about to delve into the heart of darkness. These giants could swallow entire solar systems, and their influence is felt across billions of light years. Our first stop takes us to the very edge of what we know about black holes, to a realm where even the word massive seems inadequate. We're talking about the hypothetical realm of ultramassive black holes, behemoths that dwarf even the most gargantuan supermassive black holes at the hearts of galaxies. Imagine a black hole so massive, so gravitationally dominant, that it could hold together an entire cluster of galaxies, hundreds or even thousands of galaxies caught in its sway. The evidence for these cosmic titans is still indirect, gleaned from the peculiar movements of galaxies within certain clusters. We see these galaxies whirling around a central point with such incredible speeds that the only explanation, it seems, is the presence of an unseen gravitational anchor of unimaginable scale. Take, for instance, the galaxy cluster Abell1201. Deep within its heart, astronomers have observed the telltale signs of what could be an ultramassive black hole, a gravitational abyss, potentially exceeding 100 billion solar masses. If these objects do indeed exist, and the evidence is mounting, they would represent the very upper limits of what we know about black hole formation and evolution. One prevailing theory suggests that they are the product of mergers, of smaller black holes colliding and coalescing over eons, gradually accumulating mass with each cosmic collision. Another theory proposes that they were born in the chaotic aftermath of the Big Bang, when the universe was still in its infancy and conditions were ripe for the formation of these gravitational behemoths. Our next destination takes us some 5.7 billion light-years away to the constellation Phoenix, where we encounter a black hole of truly monstrous proportions, the central black hole of the Phoenix cluster, Phoenix A. This behemoth tips the cosmic scales at an estimated 100 billion solar masses, a figure that beggars belief even as we try to grasp its immensity. To put it into perspective, that's roughly equivalent to the mass of 100,000 supermassive black holes like the one lurking at the heart of our own Milky Way galaxy. The Phoenix cluster itself is a sight to behold, a colossal gathering of thousands of galaxies bound together by gravity's inexorable pull. And at its very core, this ultramassive black hole reigns supreme, its gravitational influence felt across millions of light years. The Phoenix cluster is home to what astronomers call a cool core, a region where hot gas, instead of being blasted away by the black hole's intense radiation, is actually cooling and falling inward. This steady inflow of material provides a veritable feast for the black hole, fueling its growth and powering one of the most luminous active galactic nuclei ever observed. The Phoenix cluster black hole's AGN is so powerful that it's actually pushing back against the surrounding gas, creating vast cavities and bubbles that ripple through the cluster. Studying this colossal black hole and its impact on the Phoenix cluster provides us with a unique opportunity to witness the interplay between these cosmic titans, to understand how black holes shape the evolution of galaxies and galaxy clusters over billions of years. Chapter 3. The Heart of a Giant. The IC1101 Black Hole. Our cosmic journey now takes us over 1 billion light-years away to the constellation Virgo, where we encounter another extraordinary black hole residing within the galaxy, IC1101. This galaxy, my friends, is not your average cosmic metropolis. It's a behemoth, a cosmic giant so vast that it makes our own Milky Way galaxy look like a mere speck of dust. Imagine a galaxy spanning millions of light-years across, a vast stellar empire containing trillions upon trillions of stars. That's IC1101, one of the largest galaxies ever discovered, a true leviathan of the cosmos. And at its heart lies a black hole worthy of such a gargantuan galaxy. This supermassive black hole is estimated to harbor a mass of over 40 billion times that of our Sun, making it one of the most massive black holes ever detected. Its event horizon, the point of no return for anything that dares to venture too close, would stretch for hundreds of billions of kilometers. The gravitational grip of this black hole is so immense that it holds together the entire galaxy. IC1101, influencing the motion of stars and gas across millions of light years. Astronomers believe that IC1101 grew to its colossal size through a series of galactic mergers, collisions of smaller galaxies that coalesced over eons to form this behemoth. And with each merger, the central black holes of these galaxies would have spiraled inward, drawn together by their mutual gravitational attraction, ultimately merging to form the supermassive black hole we observe today. So IC1101 and its monstrous black hole stand as a testament to the ever-evolving nature of the universe, a reminder that even the largest structures in the cosmos are shaped by the relentless forces of gravity and time. Chapter 4. A beacon in the abyss, the Holm-15, a black hole. Our cosmic quest now brings us to the heart of a galaxy cluster known as Abell-85, some 700 million light-years away, where we encounter a black hole of extraordinary size and significance, Holm-15A. This supermassive black hole, weighing in at a staggering 40 billion solar masses, holds the distinction of being the largest black hole whose mass has been directly measured using the movements of stars swirling around it. Imagine, if you will, a swarm of stars caught in a cosmic ballet, their movements dictated by the invisible hand of gravity emanating from a central point, the black hole. By meticulously tracking the velocities and trajectories of these stellar dancers, astronomers have been able to calculate the mass of the unseen puppeteer at the heart of it all, Holm-15A. Its event horizon would stretch for billions of kilometers, swallowing entire star systems in a single gulp. But what makes Holm-15 particularly intriguing is not just its sheer size, but also its location within a galaxy that seems surprisingly faint and diffuse for a black hole of such colossal proportions. This apparent discrepancy has led astronomers to speculate that Holm-15A may be the remnant of a merger between two even larger black holes in the distant past. By studying these gravitational titans and the scars they leave on their surroundings, we gain invaluable insights into the processes that drive the evolution of galaxies and the universe itself. Chapter 5. The Quasar's Engine, TON618. Our final destination takes us on a journey to the very edge of the observable universe, some 10.37 billion light-years away, to a distant quasar known as TON618. Now, quasars are among the most luminous objects in the universe, shining with the brilliance of trillions of suns. They are thought to be powered by supermassive black holes at the hearts of galaxies, black holes that are actively feeding on vast quantities of gas and dust. As this material spirals inward towards the event horizon, it heats up to incredible temperatures, releasing a torrent of radiation that we observe as the quasar's brilliant light. But TON618 is no ordinary quasar. It's one of the most luminous quasars ever discovered, shining with the light of over 140 trillion suns. And at its heart lies a black hole of truly staggering proportions, a cosmic monster with a mass estimated at 66 billion times that of our Sun. To put that into perspective, if we were to replace our Sun with TON618's black hole, its event horizon would stretch far beyond the orbit of Pluto, engulfing our entire solar system and then some. The sheer luminosity of TON618 suggests that this black hole is feeding at an extraordinary rate, consuming the equivalent of hundreds of Earth masses every year. The discovery of TON618 and other ultra-luminous quasars like it has revolutionized our understanding of the early universe, providing us with glimpses of a time when black holes were growing at an astonishing rate, shaping the evolution of galaxies and the cosmos as a whole. Chapter 6. Cosmic Reflections. As we conclude our journey to the cosmic abyss, we are left with a sense of awe and wonder at the sheer scale and power of these black holes. So which of these black holes blew your mind the most? Let me know in the comments below, and don't forget to like, subscribe, and hit that notification bell for more cosmic adventures. Until next time, keep looking up.